Today we're going to begin Chapter 7, and the main purpose of Chapter 7 is going to be talking about inverse variation. Now you've already learned about direct variation, and now we're going to talk about inverse variation. Before we begin, let's give a few real-life examples. If you're talking about renting a car, if you drive more miles, then the car rental cost will go up. So more miles, more costs, both are going up. That's an example of direct variation. If you are renting an apartment, if you have more roommates, then the cost of rent will go down. So more roommates going up, the cost of rent will go down. One's going up, one's going down. That's an example of inverse variation. How long it takes you to get to school. If you are driving faster, the driving time will go down. So as one goes up, the other's going down. That's an example of inverse. Driving time and distance travel. Obviously, if you don't drive as long, your distance will not be as far. Both are going down. Or if you drive more, your distance will be more, or both are going up. So an example of direct variation. And finally, your income. If you have more income, then you have the ability to spend more money. Both are going up, and that's an example of direct variation. Now let's look at page 192 of your journal. And hopefully at this point you can, in your own words, write what you think inverse variation is. The constant variation is how they are comparing, how quickly. It's kind of like a rate. So if one's going up, one's going down, how quickly is one going up and one going down? And that'll be the number in your equation. For example, if you look at your core concept, A in this equation of y equals a over x is the constant of variation. So again, in the core concept here, you can see the inverse variation equation is y equals a over x. As a review, the equation for direct variation is y equals a times x. Notice direct variation, you see multiplication, it's straight across. Inverse variation, x and y are opposite of each other. And see how I did a circle like that? Inverse variation is going to look, they're going to be opposites of each other. The graph is going to be two branches that look like this. Unless it's negative, then the two branches will be in opposite quadrants like this. Direct variation, as a review, the graph is a constant line and it always goes through the origin. Key point there, always going through the origin. Notice in both equations, the direct and inverse, we have y by itself, and when we do that, direct variation we have a times x, and in inverse variation we have a over x. So let's now move to our notes, example 1. So the first example of our notes, we want to determine if an equation is direct, inverse, or neither. Reminder, direct variation, you will see multiplication. Inverse, you'll see division, with x being on the bottom. And if you have any other extra numbers, then it's going to be neither. So the first thing we want to do is get y by itself. So in example A, to get y by itself, we're going to divide both sides by x. So I get y equals 5 over x. Notice x and y are opposites or inverses of each other. X is in the denominator, y is up top, and there's no other extra numbers except a being your constant variation of 5. So this is an example of inverse variation. Looking at B, y is already by itself. We have x, but then we have this extra number being added or subtracted to the end, and that makes this equation to be neither direct nor inverse. In C, to get y by itself, y currently is being divided by 2, so we're going to multiply both sides by 2, and we get y equals 2x. Notice we are straight across. Y and x are opposites of each other on this one on one side, one on the other. We see multiplication of a being 2 here, and this is an example of direct. There are no numbers being added or subtracted also. So it's direct variation. So now we know if an equation looks like direct. Let's look at tables of data, and we can decide if they will be direct or inverse. For our tables of data, we need to think about what a will be. So in direct variation, if we were to solve for a, or the constant variation, we're going to divide both sides by x. So then we see that a will equal y divided by x. For inverse variation, to solve for a, we're going to multiply both sides by x. So for inverse, a will equal x times y. So what we're going to do is look at our data. We're going to figure out the constant variation. If we do y divided by x and keep getting the same a, we know it'll be direct. If we do x times y to keep getting, and we keep getting the same a, we know it'll be an example of inverse. So let's look at 2a. If I try y divided by x, because this is going to tell me the a will represent direct, let's see what we get. Negative 12 divided by 2 is negative 6. Negative 6 divided by 4 is negative 6/4 reduced to negative 3/2. Already these two a's are not the same, so it's not direct. Let's decide if it's inverse by doing x times y for the a. So negative 12 times 2 is negative 24. Negative 6 times 4 is negative 24. Negative 4 times 6 is also negative 24, and so is 8 times negative 3. So we keep getting the same a by doing x times y, which is going to be an example of inverse variation. Let's look at b. So for it to be direct, the a value will be y divided by x. So 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3 is not 2. Therefore, it's not direct. Let's check to see if it's inverse by doing a, which is going to be x times y. 1 times 2 is 2. 2 times 4 is 8. Already they're not the same, so it's not inverse either. So this will be an example of neither. Finally, we're going to move to example 3. We're now going to write the equation. They want us to practice writing inverse variation. So again, our general equation for inverse, we have the y equals the constant a over x. So let's start with our equation, y equals a over x. They tell us some data to help us solve for a. If y is 4 and x is 3, we can now figure out a by plugging those numbers in. So 4 equals a over 3. Solve for a by multiplying both sides by 3, and we can see a will equal 12. So let's write our final answer. Our equation is y equals 12 over x. Now that we have our equation, we can answer whatever they want, and they want to know what y is when x is 2. So simply plug in negative 2, and we can see y will be negative 6. So review, plug in x and y into your original inverse equation, figure out what a is, and then write your final answer. And then you can answer whatever they want us to figure out. Please let me know if you have any questions on section 7.1.